Explorer-1, NASA's farthest-traveling spacecraft, continues to send back intriguing and unsettling data to Earth, even nearly 50 years after its launch. Scientists are currently investigating what initially seemed like a glitch in the spacecraft systems, as the data it has been transmitting is increasingly puzzling. Explorer-1's journey has long been a treasure trove of cosmic discoveries, and its ongoing mission into the far reaches of space is yielding increasingly mysterious information. Launched alongside Explorer-2 from NASA's Kennedy Space Center in August 1977, Explorer-1 was designed to provide invaluable insights about the universe. It was one of the first spacecraft to take advantage of a rare alignment of outer planets, utilizing a slingshot effect to propel it on its interstellar voyage. Despite its identical twin, Explorer-2, departing first, Explorer-1 managed to surpass it, becoming the primary source of data about the unknown regions of space. Its Jovian imaging project in 1978, for example, returned thousands of pictures of Jupiter, as well as the discovery of new moons like Phoebe and Métis. Explorer-1's mission was extended even further when it explored Saturn and its moons, eventually discovering several new satellites. After completing its planetary exploration, the mission transitioned into what is now known as the Explorer Interstellar Mission in January 1990, as the spacecraft continued its journey into the unknown, beyond our solar system. By 2012, Explorer-1 had reached interstellar space, crossing the heliopause and entering the interstellar medium. Its position, around 14.5 billion miles from Earth, makes it a crucial instrument for gathering data that no other spacecraft can provide. Despite its aging systems, Explorer-1 continued to function for many years, offering invaluable information about the space beyond our solar system. However, in recent years, scientists have been grappling with unexpected anomalies in the spacecraft's data. While Explorer-1 is still operational, sending back scientific information and receiving commands from Earth, the data it provides has become increasingly difficult to interpret. The spacecraft's antenna appears to be functioning well, but the reports it transmits don't always align with what's happening inside the spacecraft. While these strange signals have raised concerns, NASA has yet to initiate any of the emergency safety measures designed to protect the spacecraft from potential failures. Some experts have speculated that the spacecraft's unusual behavior might be linked to extraterrestrial interference, although this theory has been dismissed by researchers. The reality is more likely to be a result of the spacecraft's age and the complex challenges faced by its engineering team, especially considering its vast distance from Earth. At 14.5 billion miles away, the spacecraft is far beyond the reach of any rescue operation. Messages sent to Explorer-1 now take over 21 hours to reach it, and a full 42 hours for any response to return. Despite these challenges, the mission continues to captivate scientists, with the spacecraft providing vital insights into the most remote corners of space. However, the mystery surrounding its current performance remains unresolved, adding to the intrigue of this legendary mission that is now approaching the end of its 45-year journey. As Explorer-1 presses on, sending cryptic data from the depths of interstellar space, the world waits for answers that may forever change our understanding of the universe. One of NASA's most iconic spacecraft faces a significant challenge due to the impact of cosmic radiation on its electronic systems. As the spacecraft has spent more time in space, the probability of these radiation particles affecting its equipment increases, leading to irregularities in its telemetry data. Engineers have long been aware of the potential dangers posed by these high-energy cosmic rays, which can disrupt both spacecraft electronics and the health of astronauts. However, predicting or mitigating their effects remains difficult. To protect spacecraft from these dangers, engineers have implemented various strategies, such as shielding sensitive hardware, designing redundant systems, and using error-correcting codes for data transmission. Despite these precautions, cosmic rays continue to present a risk, especially to spacecraft operating in deep space for extended periods, like Explorer-1. The anomalies observed in the spacecraft's data are remarkable but not entirely unexpected, given its age and prolonged exposure to cosmic radiation. Researchers continue to monitor and analyze the data, working to identify the root causes of these irregularities and develop strategies to reduce their impact on the spacecraft's operations. Explorer-1, launched on September 5, 1977, far exceeded its original mission expectations and has provided invaluable insights into the outer reaches of our solar system and beyond. Despite its challenges, the spacecraft remains a testament to human curiosity and determination to explore the farthest reaches of space. It continues to inspire future missions and expand our understanding of the universe. Explorer 1, launched just 2 weeks after its twin Explorer 2, embarked on a journey that would take it well beyond the boundaries of our solar system into interstellar space. These missions were groundbreaking, designed to take advantage of a rare alignment of the outer planets, allowing for an extraordinary tour of Jupiter, Saturn, Uranus, and Neptune. Explorer 1, in particular, made significant discoveries during its close flybys of Jupiter and Saturn in the late 1970s and early 1980s. In 1979, it explored Jupiter's moons, capturing remarkable images and data about its 4 largest moons: Io, Europa, Ganymede, and Callisto. These moons revealed dynamic volcanoes on Io, icy surfaces on Europa, and the possibility of a subsurface ocean, sparking scientific interest in the potential for life beyond Earth. After its success at Jupiter, Explorer 1 continued its journey toward Saturn. In 1980, the spacecraft provided detailed images of Saturn's complex ring system and its fascinating moons, making groundbreaking discoveries about the interactions between the particles in Saturn's rings. The spacecraft also discovered new moons around Saturn, enhancing our understanding of the planet's satellite system. Once it had completed its primary mission objectives at Saturn, Explorer 1 entered a new phase of exploration. Its trajectory took it out of the plane of the solar system and on a path toward interstellar space. In 1990, Explorer 1 captured the iconic pale blue dot image, showing Earth as a tiny speck in the vastness of space. This powerful image remains a poignant reminder of humanity's place in the universe and a symbol of the enduring legacy of the Explorer missions. Despite the harsh conditions of deep space, Explorer 1 continued to transmit valuable scientific data back to Earth, measuring cosmic radiation, magnetic fields, and plasma waves as it crossed the heliopause, the boundary marking the transition from the solar wind to the interstellar medium. In 2012, Explorer 1 officially became the first human-made object to enter interstellar space, surpassing all expectations. Originally designed for a 5-year mission, Explorer 1 has continued to operate for over 40 years, with its nuclear power generators providing the electrical power necessary for its instruments and communication systems to remain functional. In recent years, the spacecraft has experienced anomalies in its telemetry data, which have raised concerns among mission scientists. These irregularities are believed to be caused by cosmic rays affecting the spacecraft's electronics, presenting new challenges for mission operators. Cosmic rays, which originate from sources such as supernovae, can penetrate spacecraft and interfere with delicate electronic components. Prolonged exposure to these high-energy particles can lead to glitches and anomalies in spacecraft systems. NASA engineers and scientists have implemented various measures to mitigate the effects of cosmic radiation on Explorer 1 and other deep space missions. These strategies include shielding sensitive hardware, using redundant systems, and developing error-correcting codes for data transmission. Despite these efforts, the unpredictable nature of cosmic radiation remains a significant challenge for spacecraft operations in deep space. The recent telemetry anomalies in Explorer 1's data have required a careful and methodical approach from mission operators. Extensive diagnostics and simulations have been conducted to determine the causes of these inconsistencies and to develop potential solutions. The spacecraft's remote location, approximately 14.5 billion miles from Earth, adds complexity to troubleshooting and resolving issues in real time. The data sent back to Earth from the spacecraft takes an additional 21 hours, meaning that two-way communication between Earth and the spacecraft takes an average of 2 days. This delay makes it difficult to implement quick fixes or iterative troubleshooting methods, which are crucial for resolving complex technical issues. The engineering team must carefully plan and execute each command, accounting for various possibilities and potential outcomes. Unlike missions closer to Earth, where engineers can quickly send and receive instructions, the significant communication delay demands a more deliberate approach. Every command must be meticulously crafted to address known issues without introducing new problems, especially given the lengthy confirmation times needed to verify whether a command had the desired effect. This communication delay also limits the opportunities the engineering team has to interact with the spacecraft. Each command sent must be effective and precise, leaving little room for error. As a result, extensive testing and validation of commands are required on Earth before being transmitted to the spacecraft. In addition to communication challenges, the spacecraft itself is over 40 years old, having been launched in 1977. By today's standards, the technology on board is considered outdated. The engineering team must work with systems and components that were designed and built in the 1970s, adding another layer of complexity to the troubleshooting process. The harsh conditions of space, such as intense radiation, extreme temperatures, and micrometeoroids, have also taken their toll on the spacecraft systems. Having been exposed to these elements for more than 45 years, the wear and tear on the spacecraft's parts makes maintenance and operation even more challenging. Despite these obstacles, the engineering team remains committed to resolving the issues. They are investigating various theories about what might be causing the anomalies and testing potential solutions through simulations on Earth. This careful, methodical approach is essential, as any incorrect command could worsen the situation or result in a loss of communication with the spacecraft. The team is also relying on the redundancy built into the spacecraft systems. Like many space missions, Explorer 1 was designed with backup systems to enhance its resilience to failures. If a particular component is confirmed to be malfunctioning, the engineering team can switch to these backup systems to restore normal operations. In summary, while the challenges of diagnosing and fixing issues with Explorer 1 are significant, the engineering team is applying their expertise and experience, alongside the spacecraft's inherent durability, to address the problems. Their careful and patient approach is critical in managing the extensive communication delay and the complexities of working with a spacecraft that is both remote and aged. Despite the challenges, their efforts aim to continue Explorer 1's legacy of exploration and scientific discovery far beyond its original mission goals. The failures could be the result of cosmic rays interacting with the spacecraft's sensitive electrical systems. These high-energy particles, originating from distant supernovae or other astronomical events, travel through space at nearly the speed of light and can disrupt the spacecraft systems when they strike.